Hi all, in this video I am going to talk about MLKit. In mobile world these days we hear common terms like augmented reality, virtual reality and machine learning. MLKit deals with machine learning. Coming back to MLKit is a mobile SDK developed by Google which harnesses the power of Google Cloud Vision API, TensorFlow, Firebase, etc., which makes easier for the developers to create machine learning apps. What MLKit can do? It can recognize text, recognize barcode. You have many barcode readers available these days. How MLKit makes it different is it can intelligently identify the format of the barcode that is being scanned and decode the data. Label images, it can detect objects in a particular image and figure out what is a category of the items in the image. It can detect landmarks, it can detect face movements, whether a person is smiling, whether eyes are open. All those things can be done using MLKit. MLKit uses inbuilt model for some of these features. You can bring in your custom logic by providing custom TensorFlow models. That way it helps you to bring in your own logic or your own custom models along with MLKit. MLKit has a on-device detection as well as cloud-based detection. On-device detection doesn't require any internet because while installing the app itself, the required models are being downloaded into the app and all the processing is done on the device. Cloud detection requires connection and a paid cloud plan. In this video, I am going to walk you through the steps to integrate and use MLKit and to do operations that I have mentioned earlier. Okay, now let's dive into setting up MLKit. To set up MLKit, first we need to add Firebase support to our project. To do that, you need to go to Firebase console first. Once you log into Firebase console, you can see the projects that you have already created. So here I have my project which is already created. If I go into this, I will show you what all things needs to be added. You need to go to project settings. I have one text recognizer app for Android. When you first create a project, you would be asked to give a nickname and package name and few other information. Once you give that, you will be required to download this Google services.json file. Make sure you are giving the same package name in the Firebase console as your project is. Now go back to the project and copy the Google service.json, choose the project settings and paste it under the app folder. Now your app is ready to be recognized or ready to be connected to your Firebase account. Similarly, you can add an iOS app also. Here also you will need to provide the app nickname and the bundle identifier that you have given in your Xcode profile. Then you need to download this info.plist and add to your project. All these steps are mentioned in Firebase docs, Android setup and similarly iOS setup. Both these links I will add it to the description of the video. You can easily follow. All these steps are mentioned here. In your manifest file, you need to add the Firebase core dependency and Google Services plugin. That's enough as of now to make sure your project gets connected to the Firebase account. To make sure it's properly connected, you need to do a dry run first, which will configure all the setup between your app and your Firebase console, and you can verify whether it's properly connected by checking into the console. If it is not properly connected, you will be able to see error over there. So that's all with the setup. Now let's start into each feature. Let's start with the text recognition. Before starting into the text recognition feature, what is required for the MLKit to recognize an object or recognize anything? Vision image is one of the input to the MLKit, so that MLKit can process the image. Android, there are multiple ways of getting or creating a vision image. First would be to capture the image directly from the camera as a bitmap. Second thing is to save the image and get it from media storage. Third would be as a byte buffer or byte array. And fourth one would be directly loading a file from the file path. So those are the four major means to create a vision image, and all vision image need to be properly scaled and should be directed up. That is what it is recommended, so that the text and all the features can be read properly. In this example, we will use the method of loading a bitmap and decoding the information from the bitmap. Okay, before we start, we need to add one more dependency, which is Firebase ML Vision dependency. We need to add so that the vision models are being downloaded. And in the manifest file, you have to add com.firebase vision dependencies, and what all dependencies that we need. Text by default we have added. Now in future we will be adding label, barcode and face. Right now you don't need that. Now let's dig into the layout file first. In this layout file, I have an image view where in which we will show the snapshot of the picture that we have taken, and I have 4 buttons to do 4 different operations. One is to recognize text, one is to decode image, to label image, the other one is to scan barcode and to detect face, and there is a button to trigger the picture taking. That's it. Let's go to the main activity. In main activity, I have all the permission checks here. We need permission to take picture, we need permission to save the picture into the external storage. So all these things are done here. Now let's go to how we are capturing the bitmap. So take picture is the function that triggers the camera module. So we are invoking the media store action image capture intent. Once the image is taken, we are temporarily storing that into the directory and getting the URI value, which is passed to the on activity results result method. So from here we will get the actual picture. Once we get the picture, what we are going to do is we are going to resize the picture to make it properly fit into our preview image view. So here we are checking whether the configuration is landscape or portrait. Accordingly, we create a scale factor and create a new bitmap which properly fits in the snapshot view. This particular step is really important if you are going to use a picture directly received from the camera. One thing, it can be a thumbnail. If it is a thumbnail, there won't be any recognition happening, and if it is an actual image, it might be a bigger image or something like that, because of which the recognition won't happen. That means this method is really critical. You need to properly apply the scale factor, otherwise your recognition or decoding will not work. Okay, this is the these methods are common for all the 4 features. This is just to take a picture, save it to the external storage, and to apply the scaling factor. Okay, now let's come back to the text recognition. This is the action for when you press the recognize text button. Once you press recognize text button, we are taking the image that we captured and we are converting that image using Firebase vision image from bitmap function, and here we will get a Firebase vision image. Other than from bitmap, we have other methods like from byte buffer, from file path. All these methods are also available, but right now we will be using from bitmap. For more information on other modes of recognition, you can visit this link, which will have the methods to use byte buffer, file from path, etc. Okay, now once we have the vision image available, we need to create a dictator. So in this case, we will be creating a vision text dictator, and to the text dictator we will pass this image. So on success, you will get a list of vision text, which you will pass into another method, where in which we will loop through the vision text and find out the text. This is how it happens. Every text will have a block. We loop through each block and we find each lines, and from each line you can find each element, which is going to be words or letters, however it is arranged in the image that you are going to take. Let's say if you want only blocks of line, you need not go deep into this. You can have lines. That's it. So we have done text recognition. Now what I'm doing is, after recognizing all these text, I am just constructing a final text by concatenating a comma and showing it in an alert box. That's what I have done. Now let's see it in action. Here I am going to capture an image with the text. Once I capture, I am going to decode it. When I press the recognize text, you will see an alert box with the words parsed. Okay, next we are going to see labels. Here what we are going to do is, once we capture an image and do a label recognition, it will try to detect all the objects in the label. On device recognition supports 400 plus category labels. uh, for example, it can capture people, things, places, etc. That's what the label feature will do. You can read more on this here. Here also our steps would be the same. We need to capture an image as a bitmap. Then we are going to convert that image as a Firebase vision image, and we are going to create a vision label detector. And for images, you have to add vision image label model as a dependency, so that it will download all the pre-built image models with which the image can be processed and be recognized. Okay, so we are creating a vision label detector, and we are passing the vision image into the detect image property. If the once the image is processed successfully, you will get a list of labels with the confidence level says like the probability of the image is what it is. Let's say we are going to capture an image of a laptop. If the confidence says 95%, that means it's going to be a laptop. If the confidence states 50%, then that means it can be a different thing. On device image processing has bit of limitation with the uh, processing. The cloud based recognition is more accurate. Okay, so once the processing is over, you get a list of labels. From the label you will get the label name and the confidence level. There can be multiple labels in an image, like there can be multiple items in a picture, which you will get it as a list, and you can loop through and find it out. Here as the previous example that we have did, so I created one label, or I'm just taking the first item from the list of label and printing it out just for the tutorial purpose. Let's see it in action. Okay, here I'm going to take a picture of a bag, and once I press the decode image button, you can see it gives back with a confidence of 90%. Next thing we are going to see is the barcode detection. What is the difference between normal barcode application and the current MLKit? The main difference is that by default MLKit supports almost all the commonly used barcode format, and it by itself recognizes the format and decode it for you. You don't need to specifically tell this is particular format you are going to scan. That means if you scan an ISBN barcode, you will get ISBN barcode parsing result. If you scan a QR code, you will get the QR code results. You don't need to specify which barcode you are going to scan. You can read more about the barcode feature and the supported types in this link. Coming to the coding, so here also as we seen earlier, we will have a image which is a bitmap is going to be captured, and we are going to create a Firebase vision image from that particular bitmap. Then we are going to create a detector. Vision barcode detector is the barcode detector for MLKit. Here we have another option. We have there is a possibility to pass a set of options to the vision barcode detector. Like if we want to restrict the barcode scanning to some particular format, you can do like this. You can put all the allowed barcode formats in these options, and then you can pass it on to the barcode scan vision barcode detector. If you are passing any option, you should create the instance of the detector like this. Once the detector is created, you need to pass the vision image into the detect in image function. You will get a list of barcode, like as we see in the image. Also you get a list of labels. Here you will get a list of barcode. Now you need to process the barcode. So you can loop through the barcode list. You can get the bounding box corner points. Let's say if you want to draw some shapes like indicator to show where the barcode is or something like that, to add an overlay, you can use the values which you get from these particular properties. Then you have the raw value, which is going to be the value which is embedded in the barcode. Now Firebase Vision Barcode supports, by default support multiple types like Wi-Fi, URL, and other types like contact info, email, phone number, products, SMS, text, etc., calendar events. So you can handle multiple things in the using the MLKit barcode module. And each type has its own access method. For example, for Wi-Fi you will have get SSID, get password. For URL you will have get title, get URL. And if you go to other let's say SMS, you will have method like get SMS, get phone number. And for geopoint you will have get lang, get longitude. Contact info you will have person name, organization title, etc. So accordingly you can write your handlers. Here what I'm doing is I'm just reading the barcode from the list and printing it out. Here what I'm doing is I'm getting the display value from the barcode and assigning it to a text view that we have created in the UI. See the feature in action. I'm going to scan a QR code first. Once I process decode, I get the QR code value. Now I'm going to scan a normal ISBN code, and once I press decode, I get the ISBN value. So here you can see that without providing any format information, you are able to scan the barcode. Okay, next we are going to see how to detect faces and facial features. So MLKit gives a feature to detect faces and its facial features. How we are going to do is using Firebase Vision Face Detector. You can read more on what all things, like what all multiple ways you can supply face information, like bitmap, byte array, all those things you can read here. Here in this example we will follow the bitmap approach, where in which we supply a bitmap to the detector to detect. One thing which I missed in the earlier portions was like you need to add a dependency in the manifest file. So if you go to the manifest file, here we have the label for the image label, barcode for the barcode, and face as the Firebase ML Vision dependencies you need to add in the manifest file, without which the models might not be downloaded. This step is important. Okay, now coming back to decoding faces, here also you have multiple options which you can provide to the vision face detector, like what is the accuracy, what all landmark means, what all of the facial features which needs to be captured, all the classifications. Then you can set the minimum face size, whether the tracking is enabled, like if you are going to do a continuous recording or video tracking, you can enable this. With this option you can create the face detector, vision face detector. Here also we will be passing the image that we are capturing using the camera to the detectors detect in image function, and you will get, as a response, you will get a list of faces. Let's say in a picture, if you have multiple people, you will get multiple faces, and you can loop through each face. Here also you will get the bounding box, the angle, like using the bounding box you can probably draw a annotation or like a rectangle overlay. Then you can track all the landmarks using the Firebase vision face landmark. Like if you go inside, you can see multiple options here: mouth, eye, ear, cheek, nose, etc., which can be tracked, and you can find the position of all these things. Then you can compute the probability whether the user was smiling, or whether the user's right eye is opened, mouth is open. All these kind of things you can do. Here I am trying to detect the smiling probability. You can see like smiling, left eye open, right eye open, etc. And I'm trying to print, like if a user's smiling probability is greater than 50, you will say he's smiling, else you will just say his number. So I just added one basic text over here. That's all with the face detection. Let's see it in action. Okay, here I am scanning a picture of Joker with not much expression. So once I take a picture and I do a decode, you will be able to see that it detects the face, and it was not smiling, so I will have the expression as number. That's all. And that's all with some of the core features of MLKit with on device processing. Here we used predefined image to do the processing. Like if you want to do live processing, you have to do some more work. You have to pass the image as byte array or byte buffer array, so that you have to implement a surface view and capture the preview callbacks, and then pass on the stream array to the vision detector. uh, Probably it is a topic for a next video. I'll be trying to come up with another video showing those things, but as of now, this is what I have with me. Provide all the necessary links and link to the source code in the video description. You can try out and see it by yourself. Thank you.